Hey guys, it's Miss Delcambre. Today's Monday, March 1st, and here is a rundown of our day. So you will need to copy down the assignments. I'll go over the week in review. We'll go over Builder 21. We did our test corrections in class for my homeroom class. You need your 15.2. We did a couple of questions on the practice there. Your notes on 15.3. And then we went over a couple of questions on the 15.3 homework. So you'll need your journal, pencil and pen, glue, and notes on 15.3. The homework for today's Builder 21 and 15.3 or dash 3 worksheets, which is side and angle relationships. So real quick, let's go and take a look at our week in review. I need to move this down before that bothers me. So let me rearrange the Google Classroom setup. So there's week 8. Let's go to my Bitmoji Classroom. All right, let's take a look at what the week has for us. So we'll go to slide 3 here. All right, so this week we are going to be doing Monday, which is today, side and angle relationships of triangles. Okay, so you'll have your Builder 21 and 15.3 worksheet. I don't know why that's not written down, but let's just type that down real quick. Homework, Builder 21, and homework 15.3 worksheet. All right. So Tuesday, we are doing a triangle review and practice. We'll have, it will be in Google Classroom. It will be a couple of Google slides that you will be manipulating and working with. You'll also have your study guide that you need to be working on in order to do our Kahoot on Wednesday, because we have our test review on Wednesday. So we'll be doing a Kahoot and a Blooket, maybe a Gimkit. I haven't figured that one out. I think I may do Blooket this time. Thursday, we have our test over our triangles. And then Friday, we're going to be doing digital breakout and Prodigy on that day. And you'll have a Prodigy assignment. It will be 6 questions that you'll be working on. So that goes through what we're doing today. Let me pull up. Oops, hold on. I plug the camera in. There we go. Okay, let's just take a quick look at our builder. Let me freeze the screen right there. All right, as you see, we have some new vocabulary words: ratio, rate, unit rate, rational number, absolute value, and proportion. A couple of new words in there that you need to make sure that you look up. Remember, you can find that by going to your Google Classroom and going to that math information folder. So let me go back to our Google Classroom. Actually, you can even find it on my Bitmoji Classroom, this red folder right here. If you just click on that and click there, it will pop up. And then you can toggle through. And the ones with the yellow background are your vocabulary. So absolute value was on the previous page. Absolute value, the distance from 0 on the number line. So if I came over here, the distance, oh, there it is right there. The distance from 0 on a number line. Okay. Real quick up here on computation, they've given you an example. So 2 and 8/800 divided by 2 and 4/10. So they did a showed division, and they showed you steps to move the decimal and move the decimal on the inside and the outside, and then you divide like normal. Here we have 1/2 plus 1/4. You want to make sure they have same common denominators. So they need to have a denominator of 4 is what they would both share. So 1/4 you wouldn't change, but 1/2 you would change to 2/4. Add your numerators and you get 3/4. Absolute value, remember, is a distance away from 0 on a number line. Distance is always going to be positive, so or non-negative. So it would just be 6, 1/2, and 3, and then you have 3 more that here you need to do. Up here on this part with it says multiplying, divide, add integers. This section is adding integers. So they just showed you with some signs. 5 plus 3 equals 8. So same signs, add and keep. 5 plus -3. Different signs, subtract, and keep the sign of the largest absolute value. So I have 5 and then 3 negatives. I cancel out and I'm left with 2 positives. This is just shows an example, guys. Number line, you have to place these numbers on a number line. I believe we've done that section before. And the ratios and rates, this is just, again, showing you an example, right? A ratio 3 different ways to show 3 apples to 5 oranges. And here is rates, 12 muffins for $15. 15 is going to go on top, and the amount of muffins are on the bottom. Here we do not have a function table, but you are graphing, you're plotting these points. Look very carefully because it goes 1 space 2. So there's half marks in between there. On your bottom part of your bill on the FTP, here are sections that are already done for you. 1/3 is 0.3 with a line over it, means it's repeating decimal, which is 33 and 1/3%. 2/3 is 0.6 with a line over it, 66 and 2/3%. And of course, 3/3 is 1 whole, which is 100%. That does not change at all. Okay. So let's go to our notes real quick. Now, our notes are using the relationship between sides and angles in a triangle. So today's 3/1/2021, and we're going to go on to writing some other notes instead of using these for right now. So a key thing that we've come up with is a little abbreviation of how I can remember what angle and what side are across from each other. So my first one is LOL, and that is your longest side opposite your largest angle. Okay? So the longest side opposite your largest angle. And again, guys, you can switch them up. It doesn't matter because they can rotate. My next one is SOS. And that is, instead of longest, this is your shortest side opposite your smallest angle. So your shortest side opposite your smallest angle. And finally, because we have 3 sides of a triangle, we have our mid-size or our middle, our medium size. So I just call this the mid-size opposite your mid-size. Again, this is your mid-size side opposite your mid-size angle. Okay. So what this means, I'm going to draw a triangle over here to the side. Okay. Here's my bad triangle. I'm going to label my triangle A, B, C. All right. And so say this is 50 degrees and this is 60 degrees. And this is 70 degrees. Now, they're not accurate. Okay? And say I have the measurements of 9 centimeters, 5 centimeters, and 4 centimeters. And I need to figure out which side that is. So if I'm looking here, and I'm looking at where I'm going to put these, 9 would be my longest side. Well, I know my longest side is opposite my largest angle. So if I look at my angle measurements, B is the largest because it's 70. So I'm going to draw an arrow from 70 to opposite it. So it would be here on this line, and we would label that line AC. So it's line segment AC. Okay, if I'm looking at 5, 5 is like the middle one, so it's a mid-size. If I'm looking between 50 and 60, 60 would be my mid-size. So I'm going to go opposite 60, and I'm pointing to that line, which is line segment AB. Okay, and then finally, if I look at 4 centimeters, it's the smallest or shortest side, opposite the smallest angle, and 50 degrees is the smallest. So if I draw a line opposite, it's pointing to line segment BC. Okay, and this way will work every single time. Okay, so let's start back. All right, so we've already figured out our angles and correspondent to what our sides would be. I'm recording. All right, so let's look at another triangle real quick. Okay, so we're going to draw another triangle. Oh, would be helpful if I put it under. Okay, so I have another triangle right here. I'm going to draw, and I'm going to label this X, Y, and Z. Now, I needed to find what the sides were. Now I'm going to find what the angles could be. So I have an 80-degree angle, a 60-degree angle, and a 40-degree angle. And I need to figure out where I'm going to put that. So, but I'm going to give you, they're going to give you some sides here. So I'm going to put my length as 13 centimeters, 20 centimeters, and 18 centimeters. Okay. Hey, Albert, grab that graphic motion. So if I'm looking at where these would be, I'm going to look and see which one's my largest. Well, 80 degrees is my largest. Well, which side's my largest? Well, 20 is my largest. So I'm looking for what's opposite 20, which should be angle Y. Okay. Now let's look 60. 60 is my mid size. If I'm looking at these two sides, I have 18 and 13. 18 would be my middle one. So it's opposite angle X. That's where it would be, angle X. And finally, 40 degrees is my shortest one. So the only one left I have is Z, and it's across from 13 centimeters, which is also the shortest. So angle Z would be the mid size. Okay. Now, when we turn our page over, all this information just said the same thing that we just did. So triangle AB, here we go, has a side lengths of 11, 16, and 19. So we have 11, 16, and 19. So if I'm looking, 11's the smallest. So which one's the smallest angle? Is 35 degrees. So what's across from 35 degrees is angle B, or line segment BC. So BC would be 11. So we have that one done. 16 would be the middle size. So if I'm looking and comparing 88 and 57, 57 would be in the middle, and it's opposite AB. So AB's length would be 16. And finally, 19 is the largest. 88 is the largest. And it is opposite AC. So this would be 19 degrees, or 19 centimeters, inches. It doesn't give me unit of measurement. Oh. Okay. So if I'm looking at this next one, triangle AC, hold on for 1 second. All right, so here we go again. All right, so the bottom part, triangle ABC, has angle measures of 45 degrees, 58 degrees, and 77 degrees. So I'm just going to write that to the side so I can remember. 45, 58, and 77. Okay? So match each angle with its correct measure. Well, if I'm looking at the angles, 45 is my smallest. 45 is my smallest. Well, if I look at the sides, 6, 5, and 7, 5 is the smallest side or the shortest side. So I'm going opposite of 5, and it's pointing to angle A. So angle A would be the smallest one, which is 45 degrees. So angle A would be 45 degrees. If I look at measurement of 58 degrees, that's the one that fell in the middle. So between 6 and 7, 6 would be the next smallest one. So what's opposite 6? I'm going to take my line. I'm going to make an arrow pointing to the opposite, and it's pointing to angle B. So angle B would be 58 degrees. All right. Do you see how I'm getting and finding my angle measurements? All right. So the last one I have is 77 degrees, which I only have one more angle left, making that angle C, and 7's the longest side. So the largest angle would be C, which is 77 degrees. Okay. So if I'm looking at this bottom question here, it says a fence around a rock garden is in the shape of a right triangle. So first thing I'm going to do, because I don't have a picture of it, is I'm going to draw a picture of it. So over in that blank spot, I'm going to draw a right triangle. Remember, it looks like an L, has a box in the corner, and then I connect to form my hypotenuse. You'll learn more about hypotenuse when you get to middle school and Pythagorean theorem. Okay? Two angle measures are 30 and 60. Well, I know if this is 90 degrees, that can't be, the bottom square cannot be 30 or 60. So that's 90. So this I'm going to put as 30 at the bottom, and up at the top, I'm going to put 60 degrees. Okay? Two sides measure 10 feet and 17 3/10 feet. The total length of the fence is 47.3 feet. How long is the side of the opposite side? How long is the side opposite the right angle? So what I need to do is I need to write an equation. So I have my information. I know I have two of them that total this, and the whole total around it, the perimeter of it, is 47.3. And I know that one of these is 10 and one of these is 17.3. Well, if I look, 30 degrees is my smallest angle, so it's opposite my smallest side. So across from 30 degrees would be 10 feet. Okay, making across from 60 degrees, 17.3 feet. So now I just have to figure out what this is. So remember, we need to find a fence is kind of like perimeter, so we add up all the sides. So to add them up, we take what we know is 10 plus 17.3 plus, I don't know what this is, let's just put X, is equal to 47.3. So if we add up what we know, so we have 10 and 17 and a half gives me 27 and a half. 10 and 17 3/10 gives me 27 3/10 plus X is equal to 47.3. So then we need to subtract that 27 3/10 from each side, which X would give me 20 feet. So the amount on the how long is the opposite side of the right angle, meaning how long is the hypotenuse, which would be 20 feet. So 20 feet is opposite the right angle. No matter what you have, especially with right triangles, whatever is opposite the right angle will always be the longest. The right angle is basically whatever's opposite. It's called the hypotenuse. That's what you'll learn next year when you get into something called the Pythagorean theorem. And that is what we're talking about. And this dimension is always longer than the legs, kind of like when you're looking at TVs, they measure on the diagonal. So it's basically the diagonal of it. All right. So that does it for me today on the notes. If you have any questions, let me know, and we will talk to you later. Bye.